in two parts. We're going to solve log equations today, and then log exponentials in part 2. So we'll just concentrate on log equation solving. So make sure you follow the homework, specifically certain numbers, otherwise you won't know how to do it, right? Because I'm splitting this into two parts. Got it? Okay. So what are the restrictions of log of x base b equals y? And if you forgot what that looks like, it looks like a graph that looks like this, right? And this goes through, of course, 1, 0. And we have an asymptote going this way, yeah? So b can't be 0. Can it be negative? What does b represent if I change this into exponential? B to the power y equals x. So b cannot not only be 0. I'm sorry? Well, look at this base here, you guys. Can we have 1 even? Do we have negatives? Can't be negative. It has to be larger than 1, yeah. Okay. Oh, but we can have fractions. So I'm gonna actually take it as it has to be greater than 0, but not equal to 1. There you go. Do you see what I'm saying? It has to be positive. Yes? Okay, what about x, the argument? Sometimes it's easier to see it there. It can't be negative, so it has to be greater than 0. Can it be 0? Yeah. Can you have a 0 here? No. Can you get anything? Yeah. Okay, so what about y? Can you have negatives? Look at my graph here. Yeah, so y can be anything. Okay, so we'll just say y-er. There you go. I don't have enough room to do it. There you go. Okay, so you got to watch that when you're doing these solving, because you might get a solution and then you have to reject it based on these restrictions. So the process, of course, is to combine all logs on one side as a single log. That's what we were practicing yesterday's homework. Have the other side of the equation as a constant. The constant can be 0, it can be something else, but yes, have it as a constant. Then we're going to undo logs, right? This is a process of algebra. We're undoing things. So how do you undo logs? Exponentialize. So we're going to change it to an exponent form and solve the equation. And we need to reject solutions as logs of 0 and negatives are impossible. Everybody got that? Okay, so can anybody tell me the restrictions on x? Yeah, x has to be greater than 0. So we're going to reject anything that will not be greater than 0. So this one's a pretty simplistic one. You probably already solved one like this before. So it's already got the logs on one side as a single log. It's already got a constant on the other side. So now we're going to exponentialize. So what does this become? 2 to the power 3 equals x. Yes? So x equals 8. And that we have to check our restriction and make sure that's a legit answer, and it is. Okay, so b. Can anybody tell me the restriction here? I'm sorry? X has to be greater than -2. Very good. And if you didn't know, this whole argument has to be greater than 0. So then if I move the 2 over, do you see x has to be greater than -2? Okay, so process again. Write all the logs as a single log on one side equal to a constant. So the first step, I'm just going to move the logs over. So log of x plus 2 minus log of 50 equals -1. Everybody good with that? Yes? Now we have to write this as a single log. Who can tell me what this is as a single log? Yes, subtraction becomes the denominator. So this is going to be x plus 2 over 50 equals -1. Any questions there? Okay. Next step. Change the logarithm into exponential form. What's the base of the log? It's 10. So when I change this to exponent form, it's going to be 10 to the power -1 equals x plus 2 over 50. Any questions there? That to the power of that equals the argument. Yes? Okay, I don't like 10 to the power -1, so what is that? 1/10 equals x plus 2 over 50. Can everybody see I can cross multiply? 50 times 1 divided by 10 is 5. So 5 equals x plus 2. Move the 2 over. I get 3 equals x. Is that a legit answer? Yes. 50 times 1 divided by 10 is 5. Yeah? Okay. You want to try some on your own? Not yet? Does anybody see what this is equal to right here? What is it equal to? I think it's much easier if you just write that as 1. I don't know why they would do that unless they're trying to trick you. Yeah? Okay, what's the restriction? Now, there's 2 things going on here with restrictions. There's something going on here and something going on here. So we have to make a decision on what the restriction is. Because if one makes the other one undefined, then that means it's the overriding restriction. So what is this restriction here? Yeah, x has to be greater than -2. What has to be here? X has to be greater than +3. So what is the overriding restriction? And if you're having trouble deciding which one it is, think, well, if it has to be greater than, say, -2, would 0 work here? Well, it would. It says it would. What about here? No. So do you see? It's very clear that this is the overriding restriction, right? So x has to be greater than 3 for it to work. Yeah? Does anybody need me to go over that again? We're good? Okay. So I'm going to write this as a single log now. So what is that? Yes, x plus 2 divided by x minus 3. Next step. Very algorithmic. Same thing over and over and over again. As long as you practice, these are easy, right? But you have to practice these. So next step. 4 to the power 1 equals x plus 2 over x minus 3. Cross multiply. Yes? 4 to the power 1 times x minus 3 is 4x minus 12 equals x plus 2. I cross multiplied the x minus 3 times the 4 to the power 1, so that's how I got 4x minus 12. Yeah? Okay, I'm going to move the x over, so I get 3x. I'm going to move the 12 over, so I'm going to get 14. So x equals 14 over 3. Is that greater than 3? Okay, so this is a restriction as x has to be greater than 0. This has to be x has to be greater than 3. So x is greater than 3 as my restriction, right? Because it's more restrictive. So I write it as a single log. So that is, you need a bracket, right? X times x minus 3. You could probably multiply it in the same step. Nobody's saying you can't. So log of bracket x squared minus 3x equals 1. Yes? So now I'm going to change it into exponential. 10 to the power 1 equals x squared minus 3x. So 0 equals x squared minus 3x minus 10. Factor, make sure you don't drop the equals 0. You'll lose an error code. X minus 5, x plus 2, which means x equals 5 and negative 2. I saw 5 and 2 from here. So I'm going to reject the negative 2. Did everybody get 5 and negative 2 and reject it? And make sure you don't make the rejection so unbelievably rejected that I can't read the negative 2 behind it, okay? So, okay, moving on. You guys want to try this one?
Well, you know.
Oh, there's no constant this time. There kind of is, but I can't change log of 3 base 2 into a constant. It would be a decimal irrational number, right? So I'm going to leave it as a log because we work in non-calculatorville on these questions. Does everybody understand this is non-calculator? Okay. So we're going to move all the logs over to the other side. Okay. I can't just drop the equal 0, so that means it has to, sorry, I can't just drop the equal sign, so it has to equal 0 because I moved everything over. What's my restriction? X is greater than 2. Very good. Okay, so does everybody know what to do at this point? We got to write it as a single log. So, yeah, and so you can actually do the step of multiplying if you are, right? Does everybody see? The 3 will go on the bottom, and the x and the x minus 2 are going to be on the top multiplied. So I'm just going to multiply it. So I get x squared minus 2x. Everybody good with that? Okay, what's the next step? Change it to exponential. I'm going to go up here. So 2 to the power 0 equals x squared minus 2x divided by 3. I'm going to do a cross multiply. What's 2 to the power 0 times 3? 3. So 3 equals x squared minus 2x. How do I solve a quadratic? We better hope it factors. Move the 3 over. X squared minus 2x minus 3. Honestly, you will not get one that won't factor because they're all going to be whole numbers, right? So if it doesn't factor, you did something wrong somewhere, right? So positive 1, negative 3. So that means it is negative 1, positive 3. So I'm going to reject negative 1. Yes? Everybody good with that? Okay, so this is just throw some stuff on here and see if you can handle it. How do we solve this? This is a non-calculator part. This was on the exam, that's why I threw it up there. I'm sorry? The 1 to the power 1? Like the 7? No. How do we solve exponentials without a calculator? We have to try to get the same base. Can we make 1 the same base as 7 or 7 the same base as 1? 1 the same base as 7. What would that be? What do you mean times it by 7? No. Yes, 7 to the power 0 would be 1. Whoops. Now it's the same base, yes? The bases are the same, then x plus 3 equals 0, so that means x equals negative 3. You probably could have guessed and checked and got that to work anyways, right? Like what plus 3 would give you an exponent that's 7 to the power to give, the only way that it would be is if it was 7 to the power 0, right? Okay, how about this one? Huh? I heard it was 4. No? Does anybody know what this equals? 2. So 4 to the power 2 equals x, so x equals 16. Bam, done. Moving on. They had this one on that one before, on the exam before. Does anybody think they know how they would do it? How? I showed this to you once, and I don't know if you'll see it again until the review, because it's not in the textbook as a question, but they've asked this on the exam. So I throw this as an example. And this is the one I show as a happy face again. What do you mean no one likes the happy face? I'm going to make the happy face bigger. Okay, there we go. What happens if this was log of happy face base 3? So yes, 3 to the power 1 would equal, I'm going to clone it, equals the happy face. Does everybody see? But obviously it's not a happy face. Don't do that. Don't do it. This is just supposed to be a mnemonic that you remember. Oh yeah, I remember Mrs. Ramsey doing this back in the day with the happy faces. So, no, don't draw happy. You're introducing a variable without telling what it is. Yeah, you're introducing a variable. Stop it. Does everybody see that that is equal to that now? Yes? So that means this is 3 equals log of x base 2. What do? We do change it in an exponential again. So 2 to the power 3 equals x, so x is 8. But again, you probably could have guessed and checked this. You know what I mean? Like, log of what base 3 would give me 1? Log of 3 base 3. So that means this has to equal base 3. So how would that work? You know, this would have to be an 8 for that, the whole thing to be 3. You know what I mean? Okay, next one. What's the restriction on the x? It has to be greater than 0. Oh, yeah, we probably should have. X has to be greater than 0. They're all x has to be greater than 0. Not any of A and B's. By the way, depending on how I word the test, I may or may not ask for restrictions, but that should be an automatic. And even in tonight's homework, they might not ask for the restrictions. That should be an automatic, okay? Because you need to know what the restrictions are in order to reject, right? Yeah. Okay. No, we can't have a base of 1. So, x, how do we do this? How do we undo a log? Exponentialize. So, what does this become? X to the power negative 3 over 2 equals 8. How do I get it to what x to the power 1 is? How do I go from this step to this step? We need to power it to the reciprocal, not times it by the reciprocal. I know you're actually saying what I mean, but you're not actually saying it the correct way. So we're going to power it to the reciprocal. Yeah? The reciprocal would be negative 2 over 3 to both sides, yes? Does everybody see that if you power both sides by the reciprocal, the 3's will cancel, the 2's will cancel, and the negative will cancel, and I get x to the power 1. So, it's the cube root of 8 to the power negative 2. What's the cube root of 8? 2. 2 to the power negative 2. 1 over 4. Beautiful.